Well, this is John Black, Super Chemist, here on part 2 of how to make P2P via friedel alkylation, alkylation. And going back to the amount of iron tribromide you need, catalyst, like I said, I'm just guessing. It may be 3 or 4 times as much as I'm saying, but I doubt it's more than that much. Like I said, you're going to make it as you use it, and using a little bit of it helps regulate the temperature of the reaction, because if you have just a little bit in there, catalytic amount, then it can only react with that amount of the acetone to make the carbocation, you know what I mean? And then once the carbocation reacts with the benzene, then it gets regenerated. That takes time, you know what I mean? And if you only have 10 molecules of iron tribromide in there, those 10 molecules can only react with 10 things, and then they have to wait until it goes through the reaction completely before it's regenerated, you know what I mean? So you don't want to put a whole bunch in, that's for sure. Now, you're done because it stopped bubbling, right? You're not making any more hydrogen bromide. And at that point, you can even, if you're not sure, you can maybe throw just a slightly little bit more of iron tribromide in there. And how much you put in of the tribromide, at first put just a little bit in. See if it if it bubbles and it constantly bubbles, then hey, that's good enough, you know what I'm saying? You don't have to add no more in. It's doing the reaction. So you're done when it stops bubbling, and it won't bubble anymore even if you put some more iron tribromide in there. I would probably still start for about 15-20 minutes after that. Why not, right? Make sure that it all reacted. And then I'm guessing, and this is a total guess, maybe this reaction takes 30 to 45 minutes for small reactions. Maybe micro reactions, maybe it take 15 to 30 minutes or something, you know what I mean? But like I said, I'm just guessing. You just have to use, some type of common sense on the bubbling, you know what I mean? So when you're done, you're completely done. You'd have to filter out all that salt you put in, your iron tribromide. Then what you have left, you can wash it with some water, right? It'll split up into 2 layers. You keep the layer that has the benzene in it, because that is where your P2P will be. And then you wash it again, with some, and always cold water, when you do washings, do them cold. Next, wash with some sodium bicarbonate, and that'll help neutralize any of the acid that's in there. And then, it'll form 2 layers. Obviously, take the benzene layer that has your P2P. Throw some calcium chloride in there that's anhydrous, or some anhydrous magnesium sulfate, or even molecular sieves, and dry up what you have left. Then take that, filter out, your salt that you just dried it with, and then take that and distill it. Distill out your benzene, right? Then take what you have left, purify it with a sodium bisulfite adduct, right? Now that'll purify, that'll pull out all your ketones, but the thing is you're going to have a little bit of benzene in there that got double alkylated, meaning there's 2 acetones attached to it, pair to each other. But that probably has a very high boiling point compared to P2P. I haven't looked it up, but I'm guessing it's going to be a lot more. Might even be a solid. But you take your adduct and you turn it back into the ketones, right? You'll have your P2P and you'll have your double acetone benzene thing, you know what I mean? It got double alkylated. They should have a good enough boiling point differential that you should be able to distill out your P2P and leave the impurities in the pot, right? You have to do this at, I'd use a vacuum, unless you're just working with 1 or 2 milliliters or something like that. If you have 20, 40 milliliters or something, I'd do it with a vacuum, so it doesn't decompose, because P2P has like a very high boiling point. And basically that's it. That's the end of how I would do it if I tried it. My first try, this is how I would guess to do it. Keep in mind, I've never made iron tribromide, but here's a couple ideas on how to do it. You can see up on top there, you have a glass hook. Basically get a glass rod and, heat it up with a torch. Make sure you have a hook on it. Hook your steel wool that you just buy at the supermarket or whatever. And that's basically just iron and a little bit of carbon in it. Heat it up, and see the flask there? The flask has you only need a little bit of bromine, you know what I mean? Heat it up, and you don't even have to heat bromine. It fumes by itself pretty much. And heat up the steel wool with like a torch real quick and dip it into the flask. And you'll know it's working because you'll see white dust all over the place. Iron tribromide is actually a reddish brown, not a white. But it'll look kind of white when it's in a film, it'll look like a dirty white in the flask and on the steel wool. I don't know if you can collect it that way, if it would be a good way to do it, because I think a lot of the product would be put on the sides of the flask, and you'd have to try to scrape that off, and it would just be like a thin film, you know what I mean? So it'd be tough to maybe get it, but you can see down at the bottom there where I have the test tube, right? You got the bromine, a little bit of bromine in there. You got your steel wool. You heat up the steel wool. You shove it in there, and by the time you get in there, bromine fumes, so there's fumes all over the place. The reaction should take place, and because the steel wool is so enclosed, I think that the iron tribromide powder would all kind of cling to that steel wool there that's left, you know what I mean? You might have a clump now, whereas you can pour that out, not pour it out because you don't want the bromine touching it, but you can scrape that steel wool out and just use the steel wool. I mean, it's just iron and carbon, whatever didn't react, or, put it over some paper and try and, hit it with a stir rod or something to shake off the iron tribromide, you know what I mean? That way you have an anhydrous, and you only need a little bit, you know what I mean? I mean, if you're trying to make tons of it, I don't know what to tell you, but if you're just doing like little experiments, then this might be a good idea, you know what I mean? Whereas you can get all the salt kind of clinging onto that metal, and just throw the metal in. I don't know if that'll screw the reaction up, having iron metal in there. I don't think it will, though. But you could always, like I said, try and clean it off, like hit it with a stir rod, the steel wool, and let the powder kind of cling off of there, and then use a magnet to get the metal out, you know what I mean? So you have pure salt. You could do that. But these are just suggestions. I've never done it, but you can't just make it in water, you know what I mean? Because for one, it would be hydrated. It wouldn't be anhydrous. Now the top equation is what we've been talking about during this video. The bottom equation is the same reaction, but instead of using bromoacetone, you use methyl bromide. And because methyl bromide has a lower boiling point temperature, has a pretty low, I mean, it's a gas at room temperature. I think it is. I can't remember. But anyways, since it has such a low boiling point, you might want to make the reaction be at -5 to -10°C. I'd have to look up the boiling point. But you probably want it lower than 0 degrees Celsius. And you would end up making toluene or methylbenzene. The only difference in the reaction would be that temperature difference. You'd want it to be cooler. And also you have a lot more polymerization making toluene that way than you do making P2P this way. Other than that, reaction should go the same exact way. You know, you add a lot more benzene than the methyl bromide, and you know all the instructions be the exact same way to make toluene. Keep in mind, making P2P is illegal probably in most places, definitely in America probably. You know, so I don't condone anyone making it. If you make it, you do it at your own risk or whatever. Or any of these reactions, you do it at your own risk. And also, this reaction can explode or be so exothermic that it frosts up and comes out the top. You know what I mean? Like when you open a can of pop that you just shook up, you know, you shake the pop up, you open it up, and all the CO2 spills out. Well, that can happen with this reaction if you do it too fast and too hot. You know what I mean? So keep that in mind too. You get a whole bunch of, you know, acidy benzene, hot bromoacetane on your face because it all splurted out all over the room. That's your own fault. And also, if it's illegal in the place you're doing it, making it, that's your fault too. Anyways, you all have a great day, and always remember, science is great.